Alright, so we're going over quadratic functions. It says determine the equation of the parabola with roots 2 plus root 3 and 2 minus root 3 passing through this point. Now, first thing you need to know is there are three major forms. We have our standard form of quadratic. Okay, and this is one that relates to the quadratic formula. It needs to be in this form in order to plug numbers into the quadratic formula. Ax squared plus bx plus c. That's called your standard. Then from standard, we'll talk about the ways to get from one to the other. Actually, this will be a little flow chart here. So we have our standard form. Then we have our factored. And our factored form is f at x is equal to, again, a, x minus r, and s are usually the letters they use. So here's an a. The a value is the same, and r and s deal with your roots. Okay? And finally, one of the other forms they talk about is a vertex form. Vertex is a form where it's very easy to see the vertex. That's the idea behind it. So again, we still have an a. The a is the same throughout all three forms. H stands for the x value of the vertex, and k stands for the y value of the vertex. Now, to get from one to the other, to get from standard to factored, well, we factor. From get to standard to vertex, we complete the square. To get from factored to vertex, we find the axis of symmetry, and then we plug in values. Okay, so I'm just going to write this as steps. Step 1 is to find the axis of symmetry, which is a little formula r plus s divided by 2. Gives you the x value of the vertex. And then you would plug in for y value, I'm going to say. Which means once you have the x value of the axis of symmetry, you plug that value back into the equation and you find the y value of the vertex. And these will give you your x and y values of the vertex, which are your h and your k. Okay, there's really not an name to it, it's a couple steps. And then, to go from both of these, you expand and simplify to go back to standard. So whether it's going from vertex to factored or factored to standard, we expand and simplify. Yeah. So there's three major forms we deal with, and we go back and forth between them constantly with quadratics. Okay. Standard form is what most come in. Factor form will tell us the x-intercepts. That's why this is important. Okay. These x-intercepts are also known as zeros or the roots, which is directly related to the question we're talking about right now. And the vertex form gives us the vertex of a parabola, which is the lowest or highest point on the parabola. All very important. Okay. So let's kind of recap here. Jump out. Determine the equation of the parabola with these roots. Well, because you've given us those roots, I'm going to go directly into my factored form because this is one of the roots, or in other words, it's an r, and this is the other root, which is an s. Okay, so we're going to plug those values into the factored form and then try to get the a value of the factored form. Okay? So, like we said, we got our factored form here. And the reason, again, we're using factored form is because they've given us roots, which are our x-intercepts. These are the points where it's going to cross the parabola. So we have an r, or sorry, that was an a, an s, and an r. An s and r are standing for the two roots they've given us. The values for the roots is, one of them is 2 plus root 3, and the other one is 2 minus root 3. So we're going to plug those into the factored form. We're also going to replace f at x with our y, essentially. Okay, y is equal to a x plus 2 plus root 3 x. Sorry. This is x minus r minus 2 plus root 3 x minus 2 minus root 3. Okay? We'll simplify those brackets. Y is equal to a. This negative sign actually gets distributed and becomes minus 2 minus root 3. And this negative sign gets distributed and we get x minus 2 plus root 3. It kind of ends up going backwards of what we originally put it into. Okay. Now, the other thing we have in this question, if we refer back to the questions, it actually told us a point it crosses. It says it crosses through the point of 2 and 5. Yes, exactly. Very important. We can sub those in for the x and the y. So our y now becomes the value of 5. And both of our x's become 2 minus root 3. And 2 minus 2 plus root 3. Which in this case becomes 5 is equal to a. This becomes 2 minus 2 is 0, so negative root 3. Times 2 minus 2 is 0 again, so plus root 3. Which actually becomes really nice for us. Because, first of all, we got our a, we're going to figure out what this is. Negative times a positive is going to be which answer? Yeah. Well, no, we're not. We're actually multiplying these when the brackets are beside each other. So a negative times a positive gives us a negative answer. So we get a negative answer. Now we're looking at root 3 multiplied by root 3. Now you might think, oh, I need to actually figure out what they are. But a root times a root will just cancel each other out. So I'm actually just...
Negative 0.
I don't know. It's going to be 3. Think of it like if I had the root of 4, as our example. Root 4 times root 4. Okay? Well, yeah, you could say it's squared, but think of it like this. The square root of 4 is the number 2.
Oh, so just ends up being negative. No, it's negative.
Yeah, and the other one, yeah. So square root of 2 is 2. 2 times 2 is just 4. Now, the reason it becomes negative is because we have a negative times a positive, so we're going to get negative the number 3 when you multiply them together. Okay. This can be represented as the negative 3a. The goal is to find out what a is, so our a value is 5 divided by negative 3. Is equal to a. We're going to leave it as a fraction right now. Okay? And the question told us, actually let's recap what the question told us. So, question says give us the equation of a parabola. Technically, what I've done is I plugged in my a value for the a. I got my r value for r, my s value for s, and I put them down in here. Technically, this is the equation of the formula. Now, they might be looking for it in a different form, which is what we were talking about before. We're in factored form right now with our equation. But it looks like the book is talking about standard form. So remember, to go from factor to standard, we have to expand and simplify. So I'm going to go back over there. I'm going to rewrite our factor form on a different page here. Oops. I'm going to rewrite this on a different page, and then we're going to expand and simplify. Okay, so here's our factored form, and we're expanding and simplifying to solve our standard form. So we could think of these as right now inside of our brackets. We're going to have to FOIL this. Now I technically have 1, 2, 3 terms in each. Okay, this is a bit complex. Another way you could look at it is if I just kind of put brackets around this. Okay. Well, then we can FOIL, because then it's binomial products, or in other words, multiplying 2 terms by 2 terms. Where when we do this x times x, and then x times what's in those brackets, and these brackets times what's x, and these brackets times what's in those brackets. Okay, we could do it that way. Another way we could do it to make this a little simpler and then plug things in. There's a lot of terms going on right now. Not every teacher will show you this, but they'll say something called a let statement. So I'm going to say let 2 minus root 3 equal, I'm just going to make up a variable z, and let 2 plus root 3 equal x, y, z, let's choose a different one, w. Okay. The reason I'm going to do that is because when I go to distribute, it's going to be a lot easier to look at. Then once I've simplified, done that distributing, I can plug these back in again after. It's up to you which way you want to do it. It may take a little longer this way, but it'll stay a lot more organized when we do it this way. So what I'm going to do now, instead of that distributive like I said, negative 5 over 3, I'm replacing x, subtract. Remember I said 2 minus 3 will be z? So this becomes z. And x minus 2 plus root 3 is w. Well, now I can FOIL easily. I have just two simple terms. So y is equal to negative 5 over 3. When I first do this, and if you remember distributive, x times negative w, and then negative z times x, negative z times negative w. These are going to give us two answers. We're going to get x squared. X times negative w will be negative xw. Negative z times x will be negative zx. And finally, negative z will be negative zw. Okay, so I've done this. Can't really simplify any farther, but what it does help me now is I can now re-plug in some values. My z's I'm going to replace with this. So this z here and this z here are going to be replaced with that bracket. And my w's I'm going to replace with this. So my w here and my w here are going to be replaced with that bracket. So this is where it's going to look a little more complex again. But at least I've distributed all of my x's properly now. It was more organized fashion than I had it before. So y equals negative 5 over 3. X squared minus x. We said w was 2 plus root 3 minus, we're going to say x again. Z was 2 minus root 3 plus, and these are multiplied by each other. 2, we're going to need more room here. Step forward. Two plus root 3 times 2 minus root 3. That will be the only real combo. They won't cancel out, actually. They're going to create stuff. Not everything always drops off. Be very careful when you're doing these things. So, y equals negative 5 over 3 x squared. This is, again, distributive property. This is x multiplied by both terms inside of here. So I'm going to end up with negative x times 2 gives me negative 2x. Negative x times root 3 gives me negative root 3x. Negative x times negative 2 gives me negative 2x. And again gives me positive root 3x. Now here, what's actually happening is a repeat of above. When I did this, and I multiplied these brackets, I got to do the same thing. 2 by 2, 2 by root 3 by 2, root 3 by root 3. Because we have two terms in each bracket, so we have to use our FOIL or distributive property. It's always going to happen if you have two separate terms in each bracket. Okay? So, like we said, the 2's got to be multiplied by both, and the root 3's got to be multiplied by both. So I'm going to do this part kind of in blue. So we have our addition sign, and we're going to put these guys back in brackets. 2 times 2 is 4. 2 times negative root 3 is, we're going to call it negative 2 root 3. That just means negative 2 times root 3. And our other one, we have positive root 3. Positive root 3 times 2 gives us positive 2 root 3. And finally, positive root 3 times negative root 3, do you remember? It's just going to be negative 3. The roots kind of drop off of each other, and because it's a positive times a negative, we get a negative number. Does that idea make sense? Okay. So there's quite a bit to go with here. Negative 5 over 3 x squared. I'm going to start collecting some like terms. Negative 2x and negative 2x can be simplified. Yeah. Now this one's a little funnier. Well, look at this. Think of this like a number 1 in front of it, okay? There's a negative 1 in front of that and a positive 1 here. Negative 1 plus 1? 0. 0 times anything is just 0. So the idea here is we have a positive and negative of the same thing, they're canceling themselves out. They're creating a 0, is what we could be saying. Okay? And now our blue, I'm going to keep it still in blue. We're going to simplify a little in there. I still have the number 4. That same idea comes into play here. I have minus 2 root 3 plus 2 root 3s. Think of it like having 2 root 3s and 2 root 3s, and one of them is a negative.
So you can just go.
These guys are going to do exactly what those guys did. They canceled themselves out. Okay? Or the correct term is they've created a 0. We don't need to write it as 0. Yeah. So we have 4 minus 3 in our brackets. So x squared minus 4x plus 1. But we're technically still not in standard form. I need to distribute, finally, negative 5 into all of these. Y equals negative 5 over 3x squared. Negative times a negative gives us a positive. 5 times 4 is 20. 20 over 3x. And 1 times that is just what the a is, negative 5 over 3. So, even though it looked like it'd be quite simple, there's a very long process to the expanding and simplifying of this question. Okay, question 16. This is very close to standard form, this question. Ax squared plus bx plus c. Our c is obviously the 1, our a is the 4, b is a little more complex. B looks like it's been split into 2 terms. Negative 3 plus 2k. K, this is what they're saying is there's apparently some unknown number in the middle of this, and they want you to try to figure out what that number is.
Do we know anything else?
We know what the a is, we know what the c is. And they've also given us some additional information. They've said that this quadratic has 2 roots. So you guys have learned something called discriminate formula. I'm just going to call it d is equal to b
Yeah, what exactly is that?
for ac. Okay. This formula, what it says is if d is greater than 0, you have 2 zeros or 2 roots. Okay, zeros or roots, that's another one. Or x-intercepts. There's so many ways to write this word. Intercepts. Okay, it just means it crosses the x-axis twice. Yeah. If d is equal to 0, you have 1 0. And if d is less than 0, you have 0 zeros or roots or x-intercepts. Yeah. Now, in this question specifically, they told us that this had 2 zeros. Or in other words, the discriminant is going to be equal to a number greater than 0.
Well, it won't be zeros.
So the number is going to be a larger number than 0. So there'll be 2 zeros.
Isn't zeros when you just like sub in?
So what it's saying is the discriminant needs to be larger than 0. So in other words, this d here needs to be greater than 0. Okay, that's what my equation is going to be. Now I do have a b, and it's these things put together. That's what b is. B is actually equal to 2k minus 3. That's what we got there. We have an a value. A is equal to 4. We're plugging that in for that. And c is equal to 1. So we're plugging those values in there. So what we have is 2k minus 3 squared minus 4 times a is 4 and c is 1. Okay? 0 is less than. This is very similar to what we were doing before, 2k minus 3 times 2k minus 3. It's distributive property again. They really want you to know your distributive property for these things. And 4 times 4 is, or negative 4 times 4 is negative 16 times 1 is negative 16. Okay, so that's kind of left on the outside. This is distributive property again. We do the first term times both and the second term times both. Okay? So 0 less than. 2k times 2k is 4k squared. 2k times negative 3 is negative 6k. Negative 3 times 2k is negative 6k. Negative 3 times negative 3 is positive 9 minus the 16 on the outside. Okay. I almost have a quadratic. It's okay. I almost have a quadratic. I'm going to simplify what's in there and drop the brackets. I'm going to get 4k squared. This becomes negative 12k. And positive 9 minus 16 is going to give us negative 7. Okay?
So,
Negative 7.
so
That's
we're adding that back in because, but what about the variable on the outside? There's zeros less than, so you don't.
this one here.
If you're adding something into here,
So you're confused on
like how do no.
how do
we
these brackets
know?
drop off?
Yeah.
Yeah, how do these brackets drop off? Okay, so
Just because.
technically you could say there's a 1 in front of this if there's nothing there. So if I distributed positive 1 to everything, is it going to change any of these numbers? No. So everything stays the same after I've multiplied by 1, and now the brackets are gone. Just like if there had been a 2 here and I brought it in, all the numbers would have doubled, but the brackets would have finally dropped off. So because there was a 1, the numbers stayed the same. We're left with positive 9 minus 16 gives us negative 7 on the outside. So now what I'm left with is a quadratic. So I can use quadratic formula to solve this. If you remember the quadratic formula, x, or in this case it's k, k is equal to negative b plus or minus the square root. And if you notice what's underneath the square root, b squared minus 4ac, is the exact same as that discriminant formula over 2a. We're in standard form of a quadratic. A is 4, b is negative 12, 7. What's going on? Where's my green area? 7 is our c. All right, so that will go in for that. This will go in for the a's, and this will go in for our b's of what we got here. So the only thing is our k is usually equal to these, right? In this case, it has to be greater than. Okay, so this question is saying it needs to be greater than something. Or we're looking for a k value that's going to be greater than instead of equal to. Quadratic formula is normally, and we'll write it in here, x. X is equal to something. In this case, we're kind of solving with k, and it's not an equal sign because we know it had to be a number greater than 0. We're looking for k greater than these numbers. So we're going to plug these in for our b's. Or sorry, for our variables. Negative b, well, that's negative 12 plus or minus the square root of. B again is negative 12 squared minus negative 4 times a is 4 and c is in this case negative 7, all divided by 2 times 4. So we'll work this out. Negative 12 gives us positive 12, plus or minus the root of negative 12 squared, yeah, 144. Negative 4 times negative 4 times 4 is 16. 16 times negative 7 is negative 112. And everything is divided by 8. 12 plus or minus the root of 144, subtract 112, is 32, divided by 8. 12 plus or minus, so we got to find the square root of 32. So second function, 32. We're looking at plus or minus, yeah, 5.656, we'll say, divided by 8. Now, this is where the question needs to split. I have a plus and minus here. Well, I'm not sure what it is. So the question needs to split. K needs to be greater than 12 plus 5.656 divided by 8. And K needs to be greater than 12 minus 5.656. Now, this one here might be K has to be less than. I'm going to revisit that in a second. But anyways, our values, K, 12, yeah, you're right, 17.656 divided by 8. This will be 12 subtract 5.656 gives us 6.344 divided by 8. 2.2, and our other one, 7.9. Okay, they've given us two numbers that are odd. We've done this earlier, and these decimals are going to be real tough to work with. I should have, and what we could have realized is this is factorable. So we're going to jump to the next page really quickly and factor this question to see what we get. Especially because we're looking at something like greater than 0. It becomes complex when we're working with something we're plugging into the quadratic formula. Okay. Let's double check by factoring this. Now in factoring, we look for the factors of the first term. We have options 4k times 1k or 2k times 2k. Factors of -7 are just 1 and 7. Okay? They need to add up to -12k. Quickly looking at this, or actually not quickly, let's try to go through it. This column, and this column. We'll practice this out. 4k times 1 would give us 4k. 1k times 7 would give 7k. This does not combine to make 12. Our other option is going across 1 by 1 and 4 by 7. Well, that gives us 28k and 1k. Definitely not going to work. So we know this first bracket is not an option. Second bracket will give us 2k and 14k. Well, I can make a combination there. So let's actually work with these. 2k and 14k. If the 14 is negative, okay, if the 14 is negative, then we can make -12k.
Yeah.
In other words, if our 7 is a negative number, we can make 14k. And it makes sense because -7 times +1 is -7. That's a proper factor. So when we go to factor this, we get 2k minus 7 and 2k plus 1. Now normally, whatever you multiply by, the 2k and minus 7 have to go in opposite brackets. So I put the 2k here and the -7 in the other, and the 2k and the 1, or 2k and +1. But because the first terms were the same, the brackets, that rule didn't work. But had they not been the same, you'd have to follow that rule. Now again, remember this was all set equal to, or greater than, sorry, I should say 0, right? We said that this needed to be greater than 0, these answers. So 0, 2k minus 7, and 2k plus 1. Greater than 0. When I bring 7 over, or just add 7 to both sides, I get 7 greater than. Okay, and when I bring the negative, or bring the 1 over, I subtract, we get 2k. Here we get k is greater than 7 over 2, which is 3.5. Now in this one, we're going to get -1/2. K is going to have to be greater than -1/2, but that doesn't logically make sense on a number line. Because if I have -1/2 and I have 7 over 2, 7 over 2 is much higher up on the number line. I have to be greater than that. Well, greater than a -1/2 would also be here. It would already encompass this. So there's some kind of oddness to this question. What should have happened is this should have been a negative, or what should have happened when a negative moved, this should have flipped this sign. In other words, saying k has to be less than 1/2. So we're looking for numbers that are less than 1/2 or greater than 7 over 2 is what we should have been looking for when we went through this question. So after a little careful deliberation, I discovered my error. -4, -7 gives us a positive number, not a negative number, which makes a big difference coming down here. This is no longer the number 32, but instead is 256, I believe. 256. Now, the square root of 256 is 16. We get a nice round number here, instead of that ridiculous decimal we had. So we're now looking for numbers greater than, let's do 12 plus 16 and 12 minus 16. Again, I'm going to get rid of these things here. Is that what it is? Gives us 28 over 8 and negative 4 over 8, which is also negative a half. And when you divide both of these by, this is 3.5? Yeah. It should become 7 over 2. Yes, when you divide both by 4, you get 7 over 2, which are the exact answers we got on the other side now. So that makes a lot more sense, because, like I said, the quadratic formula should work. It's just a thing of preferences, essentially. So when we do take a look at the both of them together, there we go. When we take a look at the both of them together, they both end up working out. There you go. After the little page issue, 7 over 2 and negative a half, 7 over 2. Whether we do quadratic or factoring, we end up at the same answer in the end.